Hi everyone, I'm Emre and I'm an EE student in the Bilkent University, and today I will present my Physics 102 project. So let's start with the theoretical background of the experiment. Capacitance is dependent on several factors, and these factors can be seen from this formula. In the formula, epsilon is the permittivity of the material between the plates, and A is the area of one of the plates, and D is the distance between the plates. As we can see from this formula, capacitance is proportional to the permittivity of the material. Also, area of the plates are proportional to the capacitance due to the larger the area of the plates, the stronger the electric field that can be created, and the more charge that can be stored. And lastly, the distance between the plates is inversely proportional to the capacitance, due to when the plates are farther apart, the electric field between them weakens, resulting in less charge being stored for given voltage. In the first part of the experiment, I used 25 cm² cardboard, 81 cm² cardboard, and 121 cm² cardboard to observe how different areas affects the capacitance of the parallel plates. Then I connected my multimeter to the parallel plates and set the distance between the plates to 1 cm and observed the effects of different areas to the capacitance. This result occurred for 25 cm² cardboards. This result occurred for 81 cm² cardboards, and this result occurred for 121 cm² cardboards. This is the data I obtained. In the second part of the experiment, I set my area to 121 cm² and observed the effects of different distances to the capacitance. This was the result for 5 cm distance, and this was the result for 10 cm distance, and lastly, this was the result for 15 cm distance. This is the data I obtained. In the third part of the experiment, to observe the effects of dielectric materials to the capacitance, I used glass and a copper and also a free space to observe these effects. These are the equipments I used. First, I used free space. Then I inserted the glass. And finally, I inserted the copper. This is the data I obtained. So in conclusion, in our experiment, we observed the factors that affect the capacitance of the parallel plates. In the first part, we observed the effects of different areas to the capacitance of the parallel plates. We used 25, 81 and 121 cm² cardboard separately and filled the table according to the result in the multimeter. We observed that as the area of the plates increased, the capacitance between the parallel plates also increased. This result aligns with our formula for the capacitance, which is C equals epsilon A divided by D. And in the second part, we observed the effects of different distances between the parallel plates to the capacitance. At first, we set the distance to be 5 cm and measured the capacitance through the multimeter. Then we applied the same process for the 10 cm and 15 cm distances and filled the table accordingly. Our results also showed that as the distance between the plates increased, our capacitance decreased. This aligns with our formula, which is C equals epsilon A divided by D. C equals epsilon A divided by D due to distance and capacitance are inversely proportional in the formula. And in the last part of the experiment, we observed the effects of different dielectric materials to the capacitance. We used free space, copper and a glass as our dielectric materials. We knew that free space has the smallest dielectric constant and copper has the largest dielectric constant. Therefore, we expected an increase in the capacitance as we increase the dielectric constant of the material, due to our formula, which is C equals epsilon A divided by D. But, however, we observed some differences between the theoretical results and experimental results. These errors can occur from the external factors such as temperature and humidity, since they can change the dielectric constant of the materials. Also, any human mistake and accuracy of the multimeter can also contribute to these errors.